Good morning, my dear students. I am Dr. Subhadra Das from University of Engineering and Management. Today I will discuss about the Engineering Chemistry Module 7, that is Electrochemistry or Electromotive Force. So I have already covered 2 lectures. This is my lecture number 3. In our previous lecture, what we have taught about, what is oxidation, some basic concepts of oxidation, reduction, how Daniel cell is working, what is salt bridge, and other things is what is standard electrode potential, what is hydrogen electrode, what is glass electrode, how glass electrode is operated to measure the pH. So these things I have already covered. Today I'll taught about one very important equation that is called Nernst equation. So Nernst equation we are using to measure the electrode potential, right? See, there are 2 new terms. One is E cell, one is E naught cell. E cell is called the electrode potential and E naught cell is called the standard electrode potential. There is a simple derivation of Nernst equation. The first, this equation delta G is equal to delta G naught plus RT ln Q. So tell me what is delta G term? In our thermodynamics we have already heard the term delta G. Delta G is called Gibbs free energy and delta G naught is the Gibbs free energy at standard condition. And what is RT ln Q? R is the universal gas constant, T is temperature in Kelvin, and Q is called reaction quotient. What is reaction quotient? It is the ratio of concentration of product divided by ratio of concentration of reactant. Now, first of all, I want to tell you what is standard electrode potential. Standard electrode potential means there are some parameters like pressure should be at 1 atmosphere, temperature should be at 25 degrees centigrade, and the concentration of your electrolyte should be at 1 molar. So if these 3 conditions are maintained, that is pressure, temperature and concentration, then if you measure the electrode potential, that electrode potential will be called standard electrode potential. But if any of the parameter like pressure is not at 1 atmosphere, concentration is not at 1 molar, temperature is not at 25 degrees centigrade, then that parameter will not be standard, but it will be called that electrode potential will called simple electrode potential. Now come to the derivation part. So delta G is equal to delta G naught plus RT ln Q. This equation we are getting from our thermodynamics part. And delta G is equal to minus NFE. You have to remember this equal term, that is delta G, standard Gibbs free energy in case of electrochemistry, is equal to minus NFE. What is N? N is the number of electron that is flowing. F is 1 Faraday, that is 96,500 coulomb, and E cell I have already told it is electrode potential of the cell. So delta G naught similarly is minus NF E naught cell. Again N is the flow number of electron that is flowing, F is 96,500 coulomb or 1 Faraday, and E naught cell is the standard electrode potential. And RT ln Q, please remember the Q term, it is the ratio of concentration of the product divided by concentration of the reactant. Now I am dividing the both side by minus NF. So what I get, if you divide by minus NF, then you are getting E is equal to E0 minus RT ln Q, right? Because you are dividing by minus NF, this term will become positive. E is equal to E0 minus RT by NF ln Q. So if you want to convert ln term, what you have to put? You have to multiply by 2.303. And if you are putting all the standard value, that is R, T, N and RT and F, you will get E cell is equal to E naught cell minus 0.0592 by N log Q. By using these Nernst equation, you can solve a numerical problem. You can also use in the log form. You can also use the ln form also. Now here I put a problem for your better understanding. See, what is the problem? Calculate the cell potential for the following. There is a cell is given. Iron is reacting with copper 2 plus. It is converted to iron 2 plus and copper 0. And the concentration of copper is given and the concentration of iron 2 plus is also given. Concentration of copper 2 plus and concentration of iron 2 plus is given. The standard electrode potential of the cell is given. So you have to measure the cell potential. That means E cell. E cell you have to measure. All other parameter is given. Now see how we are solving this equation. So using the Nernst potential, you can write E is equal to E0 minus 0.0591 by N log concentration of the reactant, concentration of the product divided by concentration of the reactant. If A and B are reacting together to give C and D, then C and D are the product and A and B are the reactant. So concentration of the product divided by concentration of the reactant giving you the reaction quotient. So you are putting over here. Now you have to put the values. E cell is equal to E naught cell minus 0.0591 by N. What is the N? N is the number of electrons that are transferring. So what will be the N for this case? See, iron here is converted to iron 2 plus. So what is the change in oxidation state? From 0 to plus 2, right? And copper 2 plus is accepting that electron and converted to copper 0. So iron losing 2 electron, it is converted to iron 2 plus. Oxidation takes place over here. And that electron will go to the copper cathode and copper 2 plus will accept that electron. It will be converted to copper 0, right? So here the change in oxidation state is plus 2 to 0. So copper is undergoing reduction. So how many electrons are flowing over here? 2 electron, right? 2 electron is left by iron. It is lost. Iron loses 2 electron. That 2 electron is going to the copper and the copper 2 plus accepting that 2 electron to convert to copper 0. So there are 2 electron transfer takes place. So here N is equal to 2. And E naught cell is given as 0.73 volt. So you are putting 0.73 volt over here, putting N is equal to 2. Now coming to the reaction quotient part. Here log concentration of product divided by concentration of the reactant. Now there are 2 products, right? Iron 2 plus aqueous solution and copper solid divided by iron solid and concentration of the copper 2 plus. Now in case of reaction quotient measurement, the concentration of the solid part will be taken as 1. So here concentration of iron 2 plus into concentration of copper, as it is solid, it is taken as 1. Same in the same way, concentration of copper 2 plus over here, and you have to take concentration of iron, but as it is solid, so you have to put 1 over here. So just remaining term is log concentration of Fe2 plus divided by concentration of copper 2 plus, right? And concentration of Fe2 plus and concentration of copper 2 plus is already given. If you put the value, you can easily calculate E cell. It is coming as 0.80 volt. Now there are different types of numerical quotient possible. Here E naught cell is given. You are putting E naught cell over here, but it may happen in some numerical quotient E cell is given and you have to calculate E naught cell. And in some numerical quotient, it may also happen E cell and E naught cell both are given. You have to calculate the concentration of the either reactant or the product. So I think you can easily solve this type of numerical question. Now coming to the another important part, that is concentration cell. Till now, for construction of the Daniell cell, we saw that we use zinc sulfate, copper sulfate, right? So two different kind of metal and two different kind of electrolyte you have used. That zinc is called the electrode and zinc sulfate is called the electrolyte. So different kind of electrode and electrolyte you have used to construct a Daniell cell. But it may also happen you are taking same electrode and same electrolyte, but you can construct a Daniell cell. Flow of electron, thus flow of electricity is also possible. How? By changing the concentration of one electrode or concentration of one electrolyte. So in concentration cell, the EMF arises because of a difference in concentration of the species involved. Concentration cell are of two types. So you can vary two factors, right? One is if you are varying the concentration of the electrode, that is called electrode concentration cell. And in the second case, if you are varying the concentration of the electrolyte, you are constructing a electrolyte concentration cell. So first I will discuss what is electrode concentration cell. In electrode concentration cell, you are taking the same electrode material, you are taking the same electrolyte material, right? Say you are taking zinc, so you are taking zinc sulfate. In another electrode also you are taking zinc sulfate. But you are varying the concentration of electrode. Here I put an example of hydrogen electrode. If you want to construct the electrode concentration cell of hydrogen, you have to put the hydrogen. You are remembering that in second lecture we have discussed about the hydrogen electrode, right? Standard hydrogen electrode. There, through the platinum wire, hydrogen will be passes at 1 atmospheric pressure and it will be bubbling up through HCl solution. If in one cell the hydrogen pressure is P1 and if in another cell the hydrogen pressure is P2, then it may construct a electrode concentration cell, because in the two electrode the pressure of hydrogen or the concentration of hydrogen is different. So for electrode concentration cell, two like electrodes at different concentration are dipping in the same solution, same electrolyte solution, same concentration of electrolyte. Two hydrogen electrode at unequal gas pressure immersed in the same solution of hydrogen ion can constitute an electrode concentration cell, and it may be represented by this way. Now second is electrolyte concentration cell. Say you are taking zinc sulfate as one half cell and zinc sulfate at another half cell. But if you are varying the concentration of zinc sulfate in both the half cell, then you can construct a electrolyte concentration cell. Say you are taking 1 molar of zinc sulfate solution in one cell and 5 molar solution of zinc sulfate in another cell as electrolyte. So you can construct by this way, by varying the concentration of the electrolyte, you can construct electrolyte concentration cell. In this cell, both the electrodes are of the same metal and these are in contact with the solution of the same ion. The concentration and hence the activities of the ions are different. If the activity is A1 and A2 in the two electrolyte solution, then the two electrolytes surrounding the electrodes will be different. So this cell can be called as electrolyte concentration cell. These are the some question I have put over here. It will be solved by you. And these are the very easy question. If you hearing the lecture carefully, you can answer all these questions. Thank you all.